Hello everybody, how's it going? Today we have problem number 8. It's about write a program that takes a number and check if it's palindrome number or not. As we explained in a previous lesson, we said that we explained the two logics that we take them in a previous lesson in this lesson. So note the palindrome number that we can read it the same from right to left and from left to right. For example, if the user inputs 1221, we read it from right to left, 1221, same like left to the right, 1221. 1221 is same when we read it from the both side. It will give us the same numbers. All right. The output it will be, so I'll let the compiler print for me on the console screen, is palindrome number. But if the user inputs 1234, we read it from right to the left. 1234 is not same like left to the right because we read it 4321. It's not same, so the compiler will print on console screen, or the output it will be is not palindrome number. So let's assume that the value is 1234 and we use with it the first logic, print the last number of the value and delete it. So the compiler will take 1234 while we're using with it the first logic, value mode 10. The compiler will take the last number of the value, which is number 4, print it for us and delete it. We'll not store it inside another variable or new variable. Let's assume that it's called a reverse number variable. The compiler will not store it there. It will delete it directly with using the first logic. But with the second logic, reverse number multiply 10 plus value mod 10, the compiler will print the last number of the value and store it in a new variable. Let's say this is the new variable, is reverse number, to have chance later to compare the reverse number with the original value that we take it from the user through the console screen. For example, if the user insert 1234 is not same as 4321, so I want the compiler print for me is not a palindrome number. All right, this is the last slide just to explain the two logics for the last time. The first logic, reverse number equal value mod 10. That's how we write it on Visual Studio. Okay, reverse variable, we'll take the reverse number name, equal value mod 10. Let's say the user insert 1234 the value. The compiler will take the last digit, print it, remove it from the original number, which means if the user insert 1234, the compiler will print for me the last number of the value. After the compiler printed for me, it will remove it, delete it from the original value, from the original number, which means the value, it will increase its number until it becomes 0. In the end, we don't have anything to compare it with the original number when we reverse it. All right, that's what the first logic do. Then repeat until the whole numbers is finished from the value. So with the 1234, it prints 4, then 3, then 2, then 1, but it never stores 4, 3, 2, 1 inside a variable or new variable as one complete number. That's why this logic is good for display but not good for comparing the original number with the reverse number later. Why? It's not good to comparing the original number with reverse number because we don't have reverse number. The compiler delete them, print it for us and delete it, print it for us, reverse it for us, start from the last number of the value, start from the another side, but delete it after print for us, delete it, not store it inside the variable that's called reverse number. That's the first logic, okay? But the second logic, reverse number equal reverse number multiply 10 plus value mod 10, the compiler or the program also takes the digits one by one, but instead of only printing them, it spells a new number step by step, starting from the another side, 4, then 43, then 432, then 4321, which means the compiler start also from the last number of the value, take it, print it, and store it inside the new variable that's called reverse number. And take number 3, store it next to the 4. And take number 2, store it next to the 3 and 4. Take number 1, store it inside next 2, 3, and 4. And in the end, you will have all the number in reverse stored in some new variable, which is reverse number. So the second logic is not all at the once. That the compiler not take it and reverse it all, flip it all. No, take it also one by one, digit by digit, step by step. But now the reverse result is saved in reverse number, and that says value can be compared with the original one. So now let's go to Visual Studio to see how we can use the two logics and what kind of result going to bring us these two logics. Let's go to Visual Studio. All right, this is our solution of problem number 8. Try the program that takes a number and check if it's palindrome number or not. What we have here, we have the same generic function that we use it already for a million times, get positive number. All right, let's open it just to let it open. Okay, same integer value, do while loop, break statement, everything same, and in the end return the value as you say here. And after that we have new function, but it's not new, we just change its a name from the previous lesson. We change its name to is palindrome number. All right, and it takes the value from the previous function. It's from Boolean data type. Let's open and see what is inside it, the logic, how we wrote it. Perfect. Is palindrome number function. First thing, we have integer original value. We declare a variable, we name it original value, because we want to take the value before we reverse it, and we switch the number that you take it from the user through the screen. Before we reverse it, we want to store it inside another variable, because in the end we want to convert it after we reverse the original value. All right, and the second line of code inside this function, we have integer reverse number, like the previous lesson, like the previous problem. Reverse number is empty, equal 0, which is initial value. We assign to reverse number 0 for initial value to not let the command bring us garbage from the memory. All right, and we use do while loop. This is the first logic, and this is the logic that it will help us to reverse the number and compare it between the original value that you take it from the user through the console screen, or the original number that you take it from the user through the console screen. The do while loop, what we have inside it, we have reverse number, which is this that we assign to it 0, equal reverse number, which means 0, multiply 10, still give me 0, plus value, let's say that the value the user installed inside it, like 1, 2, 3, 4, mod 10. All these result, it will give me in the end what? 4. It will take 4, number 4, and we'll store it inside, because we insert 1, 2, 3, 4. Take number 4, we store it inside reverse number, and reverse number, it will be already stored inside it, number 4, without the compiler deleting the last number. After the compiler taking the last value in the number, which is number 4, because the user insert 1, 2, 3, 4, compiler will take number 4, store it inside the reverse number, and will not delete number 4. Keep it for us stored inside reverse number. Opposite the first logic. The first logic, take number 4, the last value in the number, and print it for us, but not store it inside the reverse number variable, which is this variable that we assigned in the beginning here for it, 0. And in the end, we come here, while value greater than 0, yes, t greater than 0, go do the same logic, the same process, and in the end, because it's function Boolean data type, return original value equal reverse number. What does lines of code mean? Original value equal reverse number, which means the original value that you take it from the user through console screen, original value, its values come from where? It's come from the value, and the values come from where? From the parameter, and the value here of the parameters come from where? From the first function, get positive number. So when the user insert 1, 2, 3, 4, and we assign it to the variable that's called value, directly once we go inside this is palindrome number function, directly we take, or straight away we take the value that's stored inside the value, or the number that's stored inside the value variable, we assign it to original value. So original value variable stored already inside the original number that the user inserted first time through the get positive number. So return original value, which is 1, 2, 3, 4, equal reverse number is same like the original number. After we reverse it, no, it will not be same, because if the user insert 1, 2, 3, 4, when we reverse it, it will be 4, 3, 2, 1, so it's not same. The compiler will print for me is not a palindrome number. But if the original value is same like the reverse number after we reverse it, if it's same, print for me is palindrome number. Let's do run to check it out together. Perfect. Once we did run, the compiler display for us this question, please insert a positive number. 1, 2, 3, 4 is not a palindrome number. But if I will run it again and I will insert 1, 2, 2, 1 is a palindrome number. Perfect. Where I write this string is palindrome number or not palindrome number? Here in a main function. We said integer value, all right, equal get positive number, and please insert a positive number. All of this line of code already you know it. This line of code, it's me. Take the get positive number value, which is the number that the user inserted through the console screen, store it inside value, the local variable that we declared here in the main function that we call it value, okay? And we use if statement, if else statement. If is palindrome, we give it the value. Is palindrome number, print please for me this string is palindrome number. If it's not, it's not a palindrome number. How the compiler check if it's palindrome number or not palindrome number? Through the logic that we wrote it inside is palindrome number function that's actually came from Boolean data type. And by the way, you can even print it. For example, first here, when we use this logic, reverse number equal reverse number, multiply 10 plus value mod 10, the result is correct. Let's do run. 1, 2, 2, 1 is palindrome number. Why? Because 1, 2, 2, 1, we can write it in opposite way or from the left to the right, same, 1, 2, 2, 1. And when we did run also for the fourth time, 1, 2, 3, 4 is not palindrome number. Why? Because 1, 2, 3, 4 from the right to the left, when we read it from the left to the right, 4, 3, 2, 1, it's not same. It's different number, so it's not palindrome number. This is because we use this logic and it gives us the correct result. This logic not just to print the numbers, also to compare the original number with the reverse number after we reverse the original number. All right, this logic, it's help us if you want to compare and print in the same time. But if you did comment for this logic and we uncomment the first logic, it will work, but it will give us a wrong result. And if you did run now, you will see how the wrong result that we got from the compiler. Please insert a positive number 1221. 1221 is a palindrome number. Why the compiler print for me is not a palindrome number? Because the compiler printed for me, take the last number, display it as you see here, 1221, but the compiler not store it inside the reverse number variable to check later if the original number same like the reverse number, because the compiler delete them. Because we use the first logic, which is this logic, reverse number equal value mod 10. Compiler take the last number of the value, which is number 1, print it for me and delete it. Compiler here not print it for me because I didn't use cout before this line of code. If I use cout, you will see that the compiler printed for me, but at the same time not store it inside the reverse number. And now let's try it together. For example, cout less than, put all this logic between two parentheses to distinguish it between the strings from the strings. All right, and do like just this string, listen, and do run again. You will see that the compiler will print it for you, but at the same time will not store it inside the reverse number variable. Please enter a positive number 1221. Look, the compiler printed for you 1221, but also the compiler give me is not a palindrome number because it doesn't have any number reversed stored inside the reversed number variable, because compiler delete them, print it for me but delete them. So this logic, it's not good if you want to comparing the original number with reverse number. It's just good if you want to display a numbers or print them on console screen. If you did comment to this logic, the first one, and comment this one, and we use with it cout, and we put also the logic between two parentheses, right, to distinguish it between the strings from the strings, and we run a program with the second logic that it's allowed to us to comparing the original number with reverse number, and also at the same time display it for us like the previous one. 1221. Look, the compiler print for me 1 and print for me 12. Why 12? Because take 2, put it or store it next one, and take another 2, print for me for the third time 122. Take the third 2 or the third number, store it next to the 21. After that, take the last number 1, store it inside next to 21. So in the end, compiler print for you 1, 12, 122, and in the end print for you all the number, reverse it for you, also give you the correct result. Is palindrome number. And if we insert, it's not a palindrome number, if we insert like not palindrome number 1, 2, 3, 4 for example, compiler print it for you also, take it, store it for you in reverse number variable, like as you see here on console screen, 4, 4, 3, 4, 3, 2, 4, 3, 2, 1. But also told you the correct answer or give you the correct result is not a palindrome number. So what is the difference between the first logic and the second logic? The first logic is good just to display or print the numbers without reverse it to compare with the original number. And the second logic, it display the number, print the number for you on console screen, and at the same time compare the original number with the reverse number after we stored it inside the reverse number variable. So that was the lesson of today. I just will open for you the code like this we write in the main function. Okay, we use if else statement to print is palindrome number or is not palindrome number. So that was the lesson of today. Problem number A, try a program that takes a number and check if it's palindrome number or not. See you next problem, next lesson. Ciao.